In this lesson, you will learn about conditional probability. You will learn how to calculate the probability of conditional events. So conditional probability is the probability that event A will occur given that event B has already happened. So in our Venn diagram, we have our universal set. Here is all of event A, and then we have event B, and of course their intersection of A and B. So in order to be a conditional statement, we're finding the probability of event A given that event B has happened. So this has to have occurred, so we'll actually not have all of this. We're going to be able to find the probability of event A happening given that we have already happened in event B. So this is the only area that we can even have event A occurring because we're restricting it. It's the condition that event B must have occurred. So let's look at some of that probability. The notation for conditional probability is the probability of event A given that event B has occurred. So in order to calculate that, we will take the probability of their intersection and divide it by the probability of the given event, because the only way we can find the probability of that first event occurring, probability of A, is in this overlap of event B, because given that event B has already happened. So let's look at some examples. We have a class of students that took 2 exams. So let's go ahead and draw our Venn diagram circles. We have our 2 exams. I need just a little bit more room in our overlap. There we go. So the class of students took 2 exams. We have our first exam and our second exam. It says 75% of the students passed the first exam and 25% passed both exams. So 25% passed both of those exams. What is the probability that a student who passed the first exam also passed the second exam? So these 75% of students that passed the first exam would be in this part of the Venn diagram. Because we're already representing 25%, we only have 50% remaining because that total is 75%. So we are finding the probability that they passed the second exam given that they passed the first exam. What is the probability that a student who passed the first exam, so that had to happen first, was the probability that a student passed the first exam also passed the second exam. So we're finding the probability given that this first test was passed, so given that that occurred, what's the probability that they are here? So we take our 25%, we'll need to use the decimal, 0.25. You will not want to use 25 because that's not the same as 25%. So 0.25 divided by the 0.75 because we want the entire probability of that given value or that given probability, so 0.75. So let's make that a fraction, so 0.25 divided by 0.75, you can hit math 1 or math fraction and it changes it to 1/3. 1/3 as a decimal is 0.33. You could use the calculator to math decimal, and so the percent would be 33%. If you take your decimal and multiply times 100, that gives you your percentage. So the probability that a student who passed the first exam also passed the second exam, that's 33%. Let's take a look at our next example. In New York, 48% of all teenagers own a skateboard, and 39% of all teenagers own a skateboard and rollerblades. So let's set up our Venn diagram. So this one's going to be our skateboard, and this one is going to be rollerblades. We have 48% of all teenagers owning just that skateboard. So this whole circle would be representing the 48%. We have 39% who own a skateboard and rollerblades. I'm going to go ahead and make the decimal in our Venn diagram. So 0.39. So this 48%, so 48% minus the 39%, we have 9%. So 9% as a decimal, you can divide it by 100 to make it a decimal, and we have 0.09 remaining. These are the ones that are only with a skateboard and not the intersection of skateboard and rollerblades. So it's wanting to know what is the probability that a teenager owns rollerblades given, if it tells you given that the teenager owns a skateboard. So we want to know the probability that they own rollerblades given that they have a skateboard. So we take our intersection, so the 0.39, and divide it by the given, which is the skateboard. So that value was the 48%, so 0.48. You take the intersection and divide it by the given. So let's see what our fraction decimal percent would be. 0.39 divided by 0.48. Math fraction changes it to 13 over 16. Math decimal, if we round that to the nearest hundredth, so 10th hundredths place, 0.81, so that makes it 81%. So let's look at this with some tables. We have a survey of 110 high school students asked whether they prefer dogs or cats as pets. What is the probability that a student prefers dogs given that they are in the 12th grade? So we're talking about preferring dogs given that we're in the 12th grade. They do tell us it's out of 110 high school students, but be careful to know we're not talking about the entire universal set. We're only talking about this given conditional statement. So given that they're in the 12th grade, we'll need the value of those 12th graders. So 30 plus 7 is 37. That's all we're talking about is these 37 people. You could total the value of how many preferred dogs, but you actually don't even need that total. We're going to find the probability that they prefer dogs given that they're in the 12th grade. Well, the amount of people that prefer dogs and are in the 12th grade are 30. That's the intersection. And we're going to divide that by our given, so that 37. This fraction will not reduce, so we'll just go ahead and do our decimal. So 30 divided by 37. Rounded to the nearest hundredths is 0.81. So that makes it about 81%. Example number 4. We're going to find the probability that a student prefers cats is in the 10th grade. So the probability that a student prefers cats is in the 10th grade. Because this statement does not say given, we just have to read it and see which one comes first. Find the probability that a student prefers cats. So that's the group we're narrowing it down to. So So 5 plus 4 plus 6 plus 7, we will need that total. We're talking about these 22 people. Find the probability a student prefers cats is in the 10th grade. So we're doing 10th graders given that they prefer cats. Well, those that are 10th graders and prefer cats, that intersection is 4 out of the condition that we've narrowed it down to are the people that prefer cats, so 22. This fraction will reduce. We can divide both the numerator and denominator by 2. So that gives us 2 over 11. When we change that to a decimal, 2 divided by 11, rounded to the nearest hundredths, would be 0.18. So that gives us 18%. Let's take a look at example number 5. Students were asked if they are right or left-hand dominant. The results are in the table below. So it says, what is the probability that a left-handed student is female? So female and left-handed student. So it's wanting to know the probability that a left-handed student, that's our given statement, that's our condition, is a female. So we want to know the probability of a female given that they are left-handed. So we find that intersection, so 13 out of the given, because we want to narrow it down. Our condition is the left-handed. We use that total of 25. $13 divided by 25 does not reduce. That decimal is 0.52. So that is 52%. Our final example here, find the probability that a randomly chosen student is right-handed given that the student is male. So probability that they're right-handed given that they are male. So our male students are what we're narrowing it down to. We want to know what's the probability that they are right-handed. So the intersection of those is here at 47. Because we've narrowed it down, our condition was the fact that they were male students. The total number of male students is 59. That fraction will not reduce, so we take 47 divided by 59. When we round to the nearest hundredths place, here behind that is a 6 that will make this round up. When you round that up, it actually becomes a 10. So it's actually going to make this one round up to a 0.80. So that makes it 80%. Keep in mind with conditional statements, it's the probability of event A given that event B has occurred. So you're narrowing down to that condition of the event occurring. You are not talking about your universal, the entire set. You're just talking about that conditional statement. You will notice in each of our probabilities, we never divided by the total number. So in examples 3 and 4, we were told that our total was 110. We are not talking about out of the universal set. Same with number 5 and 6. Our total number is 130. We did not use that because we're not referring to our universal set. It's conditional. We're narrowing down to the condition that has been stated.